वाव खा बाय. कुठे होते ते कुठे काढले कुठे होते कुठे होते कुठे तू काढले मला पैसे काढले आम्हाला म्हणून नाही नाही घेतली मी ना तिच्या जवळची. आवाज येते की आता तुला बाबा बाबा म्हणते ते आजी आवाज आहे पहिले आजी नाही पाचशे कुठचे घेतले तिने गेले तिकडं ते कुठचे पैसे पेंशन करते पाहिजे तिच्या बॅग मध्ये पैसे काढले तिने सगळे तिच्या मी काढले माझ्या बॅग मध्ये माझ्या बॅगला हातच लावत नाही ते लाडत नाही दिसत तो नाही ते फोन स्वयंपाक करून राहील ती घेतले घेतले देऊन दिले हा पोरगीच्या हातात नाही शेतीच्या हातात ऑरेंज पाहिजे त्या पाहिजे तुला बाबा आधी हाय म्हणून हाय ना हाय आधीला विचार जेवण झालं का जेवण झालं हो का ना हो हो पण आधीला हो गुड असते तर पाहिजे त्याला गोड गोड होते फील्ड मध्ये तो अख्खा गुड आहे ना मोठा आपला तो जोडून जोडून मग तो ट्रीटमेंट ठेवला ना तो डबा उघडते आणि कोणी कोणी म्हणते असं आहे का आता हो आता काय होतं तो मानलो सुरुवात कधी येते इकडं वापस मी गेलता कोण तिला म्हटलं पाय आता आठवलं तिला म्हटलं पिंकी त्याच्यासोबत राहतो तू स्वयंपाक करून राहिली ती झालं की मग बोलीन म्हटलं व्हिडिओ कॉलवर आणि त्या दिवशी राहून गेला तो तिला 10 दिवस राहतो तिला याद नाही व हे वेदूची कणकण घात असतं की हा हा इथं स्वयंपाक पाणी झाला हा नाही, इथं स्वयंपाक पाणी झाला की लावतो, म्हणजे हे बी बोली असलेच आहे ना. हा, कसं अभ्यास करून राहिला. कांदी कांदी त्याच्या खांद्यावरच घे म्हणे, तर अर्धा एक घंटा त्याच्या खांद्यावर बसून बसून मिळते मी. आणि त्याला मुद्दाम आश्लेष काका, आशिष काका म्हणते, आशिष काका, आश्लेष काका. पण म्हणा दादा आहे ते, म्हणते नाही नाही काका. आपण म्हणा दादा, नाही म्हणते नाही काका, मुद्दाम. ते करावं मग तुम्ही आराम आता, तुमची दौलत दुनिया. हो, बेजान. तुम्ही मिळाल म्हणजे इथे बी नाही असं. त्यात धाबा गरम मस्त पैकी. ते कसं तर ते तीनाच्या थंड पडत असते. चालते, ठेवू मग मी. काय म्हणत होती का तू? हा ठीक आहे.
Mayurish, you are not audible.
You are not audible, Mayur.
Hello, am I audible now?
Yes, yes,
Yes,
sure.
you are.
Yeah. Sorry for the disturbance. I will start again. So, good evening, everyone. Myself, Mahesh Maruk, and on the behalf of PICT ACM Student Chapter, I would like to welcome you all to this exciting session on mastering GSoC and your gateway to the open source. So, today we embark on an enlightening journey into the world of open source, where ideas, collaboration, and innovation, all of these things converge to create a great opportunities for us. So now I would like to give a short intro about the GSoC, like Google Summer of Code, or we can say GSoC. It is a global platform that helps to connect student developers as well as open source organizations together world projects under some expert mentorships. So this is an good platform for the aspiring developers. I think it's an golden opportunity to learn, grow, and contribute into our impactful projects. Also, I think it helps us to build or enhance our collaboration, creativity, and I think something that a spirit of something giving back to the tech community. So now, without further ado, I would like to introduce our speaker of the session. That's Mr. Aditya Kane, sir. So he is an researcher and a passionate advocate in the field of open source development. Mr. Kane is currently pursuing his master's degree at prestigious Georgia Institute of Technology with an remarkable contributions in many of the open source organizations such as TensorFlow, such as KerasCV, etc. So his expertise extend also in a field of transformer-based vision as well as language models, showing his innovative approach in field of artificial intelligence and machine learning, as well as his tenure at Artificial Intelligence and Robotics Lab, IISc Bangalore. So he was working on a research in out of distribution and open set detection in NLP, further strengthening his position as a leader in that field. So now with such an impressive background, I think Mr. Aditya Kane sir is the best person to guide us through the GSoC and help us to understand its opportunities as well as challenges and make them clear for us. So we are truly honored to have you with us today, sir. And thank you for sharing your time for guiding us throughout the GSoC. And without any further delay, I would like to dive into the session. So over to you, sir.
So thank you for that introduction. I hope I'm audible. Um,
Yes, sir, you're audible.
sure, thanks. Mm, okay, let me try to share my screen. Okay, I hope the screen is visible. Okay, so okay, I think it is indeed visible. Okay, so let me start. So hello everyone, I am Aditya, and essentially as Mayur said, I'm right now pursuing my master's at Georgia Tech, and I'm advised by Professor Humphrey Shee. My major area of research is efficiency in deep learning, uh, essentially trying to make deep learning models go faster. And I was like, obviously I was at PICT in the past, and during that time I had contributed quite a bit to open source, and I think open source is a really important part of today's software ecosystem, and everyone should kind of at least know about it, if not contribute. Everyone should know about the good parts of open source, and everyone should sometime at least try to experience it. And that's what I want to talk about today. I want to talk about open source and uh, Google Summer of Code as well. So before we start, I'll share the slides after the talk, and stop me anytime in between if you have any questions or want me to go slower or faster. Also, I think I have contents for about 40-ish minutes, or 40-45 minutes. But I'll stop after that, and we can kind of like have a Q&A session, or like if anyone wants to talk something or whatever. So I think we'll have quite some time in the end. So today, yeah, our agenda for today is straightforward. First, we'll look into what's open source. Then we'll go through the details about GSoC. And lastly, I want to share some pointers for practicing open source. So first of all, let's get started quickly with what is open source software. And I think a lot of this is misunderstood. Most students confuse open source software with free software, and like, I mean, there's a lot of confusion around this. So what I want to first of all do is kind of clear out those things and tell exactly what is open source software and why it is good. So open source software is simply whose source code is freely available, or I should say publicly available. And when I say freely, it does not mean, I mean, it means free of cost, but in addition to that, it means that, as I said, it's publicly available. So, like a good analogy is that it's not free as in free, I don't know, free merch, but something like free speech, you know? So, the only part is that open source libraries have some kind of licenses. You might have heard about like the MIT license or the GPL license or something like that. And it just outlines the basic rules. For example, like here I have written like whether to credit the original authors or not, or like it has some statement about reproducibility. It has some statement about like kind of just taking it as is or like making changes. It outlines very basic rules for that. And as I said, this is not to be confused with free software. So the main distinction here that needs to be made is that open source software is the software whose source code is available. Now, free software is something whose source code might or might not be available. Like I'm sure like there are a lot of free applications and libraries over the internet which you can just download, but more often than not they are distributed as a binary. Like you just have a, let's say, a .exe file or something similar to that which you get. You don't necessarily get the source code behind it, or even like even most of the applications that you download, they are generally like if you are a Windows or Mac user, they are generally installed in some directory, and you just get a final binary, a .exe file, and you run that file. But essentially, you can't look within the file, or you can't look at the actual code. So essentially, that is free software, but open source software is where the source code is available. You can essentially download the source code, you can change the source code a bit, and you can build it locally. Uh, and that's the main distinction. I would believe that open source software has its source code available. Now, why does open source software matter and why is it so important? So, like one of the most paradoxical things about this thing is that it actually makes it secure. It makes it more robust and kind of less prone to bugs. So the entire premise of open source is to harness the power of like a community essentially, that many people will be looking at this code, they will be contributing to this code. So the point of the library or like this paradigm is to just kind of harness that like kind of a large scale effort to for the betterment of the library. So essentially, like here I have written it's more secure, which I essentially mean that it's kind of less prone to any errors or bugs, because when something is available widely, it is more likely than not that many people will take a look at it, provided it is good and useful. Many people will indeed look at it, which means that there will be a lot of people using it, and there will be a lot of people reporting bugs. And then many times the same people work on these bugs and contribute back to the library. So what happens is that the entire library gets better and better just because of this public effort. So that makes the library more stable, because if it's a closed source library, let's say like something like Microsoft products like the Windows OS or the Office products, like they are closed source, right? Like their source code is not available to the general public, of course, I mean, but that means that it's more prone to bugs and inconsistencies because a very small set of people, that is only the developers working on that product, are looking at the source code and trying to figure out if there are any bugs and all. But if there is some open source library, like let's say the Linux kernel, it's the biggest example of open source library. Like there are so many people contributing every year. Like there are thousands of PRs, and that's why like over the years it has gotten more and more robust. It has gotten more and more like ironclad. So that's the reason that open source indeed makes the library more secure. The second thing is obviously, as I mentioned, like it's community driven. So in the development of open source software, maintainers and like the users kind of work together. So also I should mention that most users, if they kind of have spare time or they want to contribute back, they become really good contributors because they know the product, they care about the product. In fact, that's how I started to contribute back, because I was using TensorFlow and then I felt, okay, like this seems really interesting. I should kind of look into it more. I should dig into it more. So it becomes a community driven effort that the main point of all of this is that open source gets all the benefits of having a large group of people working for the project. So uh, like the famous open source projects like the Linux kernel or TensorFlow or Torch, like or React or something like that. These can harness the power of this large group of people. But since there are a very small number of core maintainers, it's more streamlined. It's kind of that, okay, the outside community has a certain level of access and power, uh, but the maintainers can still decide that, okay, which of the contributions are good, which are not good, and so on. So it's essentially good governance. Okay, so open source software can get the benefits of having a large team, but they also can be very flexible and very agile with their movements. And like with that, I think we can kind of move on to the second part, which is essentially what's Google Summer of Code about and what's good about it and so on. So back in the day, like open source software was not a very kind of big thing initially, like especially in the initial years. I think around the turn of the millennium, it wasn't such a big thing. Uh, so like I think GSoC was started in like around 2005, and it was started to kind of open up open source as a actual thing. It was there to improve awareness about open source, and it was started by Google on a very small scale, but now it has grown to be a very big thing. And the essential theme is that participants are paired with mentors to work on like impactful projects. So every project will have some mentors, and they will be, and the participants will be paired with these mentors so that they can work on something that is actually impactful and useful. Now, I think like the best part of this is that the participants have the chance to directly work with the maintainers of the project. Sometimes, though, it happens that you also get to work with some really good community members as well, who are not directly uh, a maintainer of the repository, but they have been contributing for a long time. And like, why is it good? Like, what's in it for you? The great part is that you will work on things that will have a very solid real world impact. It's not a toy project. It's not something that's half baked. So generally, if you start to make a project of your own, more often than not, it's going to be half baked. It's not something that you can just go ahead and present it to the real world and expect a lot of traction, right? Because it needs a lot of iterations and it needs a lot of work to actually make it a usable product. But with most of these libraries, even if you contribute just a bit, you are going to have real world impact. If you kind of resolve some bugs or add some features, you will actually improve the project, and most likely many people will be using that. Another advantage is that most of the open source libraries are really well written. Like they are good pieces of code, well maintained, well written, and I think this is the best part, and this is what I felt the most. Like this was the advantage that I got from Google Summer of Code, because when you are especially like when you are in your undergrad or even like masters, access to good code is really really scarce. So like unless you work on some unless you are part of some internship which is like in a really tech-ish company, like I don't know, like one of the FANG companies or something, it's difficult to get access to good code bases. So that's why I think like this is one of the important facets, and not just Google Summer of Code, but just open source in general. It opens up access to good code bases which are really big, but they are also very well maintained. So you can actually take a look at how real code looks and how it works and how it is organized. And this actually transforms you as a developer yourself, because it kind of shows you how it needs to be done, what's the right way to do it. Otherwise you will kind of have some kind of a you will cultivate bad habits, right? That okay, I'll kind of go ahead and write code the way I think, but more often than not it is kind of a premature style of writing. So that's why, I mean, this is a big advantage that you directly get to see what's the right way to do it. And of course, as I said, like you work with maintainers and very strong community members. So you get to learn with the best people who kind of know what they are doing, who are good at it. So that actually changes a lot of things about yourself. Like you kind of start thinking in the way that they do, and you start writing code in the way that they kind of write their code. And it overall it has a very big uh, improvement on your own skills, essentially. So moving on, I'll just quickly go over the logistics of Google Summer of Code. Uh, So I've kind of taken this from the uh, timeline website of GSoC. But for anyone who doesn't know, in GSoC initially, uh, there is there are essentially like two groups, you can say. One is like the organization and one is the participant. So essentially, uh, as you can see, the first few points, the organizations are selected, like even GSoC selects these organizations. These organizations are essentially projects, like let's say FFmpeg or TensorFlow or something like that. So those are kind of selected, and their mentors are selected essentially. Like let's say some organization will have like two or three mentors, or depending on their bandwidth, they will have two or three mentors, and they will also have some project ideas. So after that, when the contributor applications start, you can take a look at those projects. So these are the projects that the organizations have kind of put out. You can take a look at those projects, or you can propose your own. It's totally fine and encouraged. You can see what suits you. You can like kind of align your skill set with that, and then you can apply. You can tell that okay, I will kind of execute this project in this way. I will kind of go like throughout the coding period, I will go like this. I'll target to add these features, or I'll try to resolve these bugs or whatever. And you need to outline all of this in your application. And and then you will kind of submit it. You'll submit it to the organization. It's recommended that you apply to just one organization. Some people tend to apply to more, but I don't really think that's useful. You should just focus on just one. And then after that, it goes into the review period. And then after that, essentially the contributors are selected for the Google Summer of Code. And generally they are selected, and then they are paired with the mentors, and then some kind of intro time to bond with the maintainers. And like this is written as the community bonding period here. It's essentially that you will kind of first decide and discuss with your mentors what should be the target of the project and target of the coding period, and exactly what are the expectations, and you just kind of prep for the coding part. Also during this time, it's like really encouraged to be really open. Really, I mean, you need to be really transparent about your efforts and like what do you want to do and so on. So after that, the actual coding period starts. So I think like Google Summer of Code has two settings, where first you have like a 4 month coding period, or you have a 6 month coding period. Uh, so that starts, and after that, essentially there are the evaluations that the mentors will evaluate the contributors, and then when the program is over, essentially the evaluations will be out and the results will be announced. So can pass or fail. So essentially, like you get to know if you have passed or not. So, but essentially, unless you are like completely lazy and don't do any work, you will pass, but provided that you do the requisite work. It's necessary that you actually do whatever you have committed to. So that's important. And this is kind of the timeline of the program, that first you look at the projects, then you apply, then you kind of have this community bonding period, then you have the coding period, and then finally there are the results. A more detailed timeline is also available. It's available at that link which I have mentioned there. But yeah, this is the rough timeline, and I kind of want to focus on these parts. Um, so as I said, the pipeline is that okay, first the projects are released and you get access to these projects. So the way it works is that these organizations already have some projects in mind that okay, we will kind of have these to be done by the community, or these features by the community. These features are generally something that the actual developers or the maintainers don't have the bandwidth, like they don't have the time to complete those things, but they would really like the libraries. So generally these are like that, or they are simply something that are purely community driven. So in my case, I had to like I was essentially implementing and merging a set of models into TensorFlow. So that is something that you would want a community member to do, and you wouldn't want a team member to work on it and spend their time on it. Instead, you would kind of take this to the community. Now, after that, of course, it's the applications. Like you need to look at these projects and see what aligns with you. Now, the important part is to select the organization and project very wisely, because you need to align with it, right? You need to work on the same thing. And it's like you cannot just go ahead and do something unless you have a pretty good idea about it, because this will require you to look at a lot of code. The code will be like really, like as I said, it will be a large code base. So it will have a kind of a steep learning curve as well. So it's kind of it's a involving process to kind of look at the projects and decide which one you want to work on. But if done correctly, it's also the most rewarding, because then you will exactly know what I need to do. So and after that, it's of course the applications. And I think like the most important part is of course the proposal, is that you need to clearly define, okay, this is the project I want to do, this is how I'm going to execute it, this is my approximate timeline, and yeah, this is how I am going to tackle the entire part. So essentially that gives the mentor some kind of assurance or some kind of idea as to, okay, this person has actually looked at it and kind of planned ahead. So it's important that you actually pay a lot of attention to this and you kind of have a good timeline and you just like you choose a part which you can do completely. So don't bite more than you can chew, right? So don't take a project that's too big or too complex, but something that's not too easy or like, I mean, which is something that can be done in a week or so. So take a good chunk of work which you can tackle and slice it up correctly, and then just write all of this down in your application. Then after that, of course, it's the selection and community bonding. So if you are selected, then your mentors will most likely contact you. You will kind of have some kind of a group introduction if it's like more than one people uh, in that in that cohort of participants. You will essentially have some kind of discussion about what are the expectations and like what is needed from you, or like what the mentors want you to do throughout this Google Summer of Code, like throughout the coding period. So in my case personally, what had happened is that I had written up a proposal. I had written it about some that I want to implement these models, sorry, in TensorFlow, and I want to add them to TensorFlow. But it turns out that those models were already being internally added, like from Google themselves, they were going to add those models. So my mentor actually suggested that I take a look at a different paper, I look at a different model, and I try to implement that. And like, yes, I looked at that thing and I kind of read it up and I saw, okay, I can do this as well. So like my project kind of changed a bit, but I think it was for the good. I had a lot of exposure to how to write such a model. Like my essentially at the time, my project was to take something from PyTorch, which is a deep learning framework. Like the entire model was written in PyTorch and kind of uh, replicate it in TensorFlow, train it from scratch. So, like, if these words are kind of a mishmash to you, you can just think that I have taken something from a different language and re-implemented it in a different language, something like that. So it was that, and so that's this happened in the community bonding period where I essentially was in touch with my mentor and like he kind of suggested that you can do something different as well. So yeah, so that was essentially the process. And after that, of course, it's like the programming period. Uh, there are some pointers which I have not written here, but it's very, very important to be very transparent in communication. Like in general also it's very beneficial to be transparent, but especially here where most likely like you are also new to everything. The maintainer also, or like the mentor, doesn't have a good idea of what you bring to the table, what are your skill sets and how are you approaching the project. In such a case, it's very important to open and ask them, okay, hey, that I am stuck upon this. Can you help me? Can we have a short call or something like that? So during my GSoC, we had like weekly meetings. And so the way I used to tackle them was I had like everything paper that, okay, these are the 4 points that I want to talk, and I would go through them one by one. Okay, this is something that I need your opinion on. This is something, and so on, because generally you will need some inputs from the mentors, right? That, okay, I am programming some feature like this, I am coding it up, like, do you want it, do you, is this okay, and something like that. Of course you can have all of this discussion directly over GitHub as well. That works perfectly well, so that it's just out in the open, publicly available. And yeah, but the point to be taken here is that communication is very important. You need to be transparent and you need to be open about what you're going through and just do everything in sync with the mentors. talked about how can you do GSoC correctly, but here are some pointers just for like open source in general. So like one or two pointers is that you need to have some kind of experience about the repo before GSoC starts. And this actually comes if you are an active contributor already. So in my case, for example, before my GSoC started, like it started in around May of 2021, but I was contributing to the library since kind of November or December of 2020 itself. And for me, it wasn't because I wanted to do GSoC. It like was over the horizon for me. But I kind of just liked TensorFlow. I liked Keras a lot. I had learned about it in some prior courses or something like online courses, and I really wanted to like look into it more and more. So I kind of was looking around their GitHub repo and something like that. And that's actually how it started. I kind of started solving issues which people post on GitHub. And most of them are like support kind of issues that people are not sure how to use the library or something like that. So you kind of help them uh, understand. And after that, like after some time, I think I had a couple of which kind of did some bug fixes, something like that. And that's how it started to snowball essentially. That okay, I kind of uh, got more and more involved. I was actually actively answering to issues, and I was actually actively trying to contribute code and so on. So it's important that you become an active contributor before GSoC starts, because in that way you will know the code. You and so when the mentorship comes along, like when the mentors are there with you, you can progress really quickly. Or otherwise, what happens is that like the first 1.5 month of the 3 month period, it just goes into understanding the code. And I mean, that's simply suboptimal. You don't want that, because like 3 months is already a short time to do something big. But if you want to maximize the impact and if you want to maximize your experience, you must know the code beforehand. Otherwise, it just like wastes a lot of your time. And that's why like I have written here, you need to be an active contributor before. So that's one thing. And like the last point is like if you are an active open source contributor already, GSoC will be really a walk in the park. Like getting in will be possible and completion will also be easy. You won't have any problems along the way. Um, Now, as I said, these are some pointers about contributing to open source. So this is kind of a roadmap or kind of a step-by-step process, which I would like to explain if someone wants to get into open source. And as I've been talking throughout the time, I will kind of try to give examples from my own time uh, of contributing to open source and try to align it with these pointers. So the first point is that, like I have written, study, study, study. Essentially, that means that you need to know the framework really well before you dive into it. Because, for example, let's take something again like TensorFlow. By the way, if someone doesn't know already, like TensorFlow is a deep learning framework mostly used in Python. But you can actually apply these pointers to any repository and any project which you want to contribute to. So the first point is to kind of just use it a lot, get acquainted with it, and get acquainted with how it works and kind of uh, how it is designed. Try to get some idea of that. So that is the most like that is the fundamental bedrock of contributing, that you essentially need to know, right? What you're contributing to. You cannot just go on GitHub and start making pull requests unless you know what the code is about. So that's the first thing, that you need to have some kind of experience with the library as a user and not as a contributor. So that's the first thing you do. Thing is that you go on GitHub, you go to the issues tab, and you start scrolling through the issues. That, okay, is there something that I can work on? You know, like And it's not that you will just directly get something, but even if you get something that you can maybe handle like 50%, you should go into it, you should read whatever's happening, and you should go back to the studying phase if you need to. Like you can go back to the source code, you can go back to the documentation, you can study more this process as long as you need to. So your first point of contact with the repo is solving the issues, right? So you go to the issues tab, you just select something that you can work on, and you start working on it essentially. So either it can just be helping out the user in their use case, or it can be request. But I think before that, there should be like one more sub point is that you should also create a GitHub issue before you create a pull request. So it's generally good practice. I mean, in some repositories, it's very advised to create a issue before create a GitHub issue before you kind of make a pull request, because then the contributors know what you are planning to contribute back. So generally this happens in the case of bug fixes or like small features, that you will first talk with the maintainers that okay, these are the things that I'm going to fix, or these are the things I'm going to add, and then you make a pull request. Then you kind of open that pull request and then you discuss the code. Because if you directly open the pull request, you will not have any idea of what you need to do, because more often than not the maintainers want the feature to have a consistent API. They want to have it written in a particular way. So it's better to discuss that before you start coding up the pull request. Okay, so you need to first go and like go through this process of like just looking at the issues, and then if you want to merge some code, you just want to create an issue first and then actually like discuss it and then actually create the PR. And like if your PR gets merged, then congratulations, it's great news. You essentially have managed to contribute most likely to a very impactful project. And this is kind of the process that you want to go through over and over, adding value to the project. So you want to see that okay, the project is written in a certain way, it's like developed in a certain way. You want to keep adding value to the project, right? And that's what open source is all about. It's about adding value to the things that are already out there. And if you continue doing this for long enough, you get to work on more and more complex PR, which require a lot of understanding about the code, which really makes you uh, uh, exposes you to the things that I mentioned before. It exposes you to good software, like really smart people, and like just the experience of contributing to a big project. And like this is essentially my roadmap for getting into open source. Uh, like feel free to just do it in any order, but I think this kind of goes a long way into creating a strong foundation as to how you want to approach open source. Now, some positive things about open source is like really, as Sayak mentions it, it's a vehicle to create opportunities. So essentially, like there are many uh, potential things or opportunities that you can do when you are practicing open source, right? So like there are quite a few which I think these are mentioned in the upcoming slides. So essentially, like if you have something you can explain better, like it's if you can just create a, let's say, a video or blog or something, and it you can just make a blog and then put it out to some blog post or anywhere essentially, or as it's written here, you can also make a demo project. So this is about like most of the times documentation is really sparse unless it's like a very big project. That's where you can just create blogs that are niche that people can actually appreciate, and that's something that you can explain better. So I think it's great to create some like this kind of a content that uh, you can actually serve to the people. And yeah, that leads to the second point, that if you can improve documentation, please do. Every project always appreciates improvements to documentation. This point, like if you want to contribute to a module or a library to improve it, this is something that I mentioned in my earlier slide, that if you want to go ahead and kind of contribute some bug fixes or feature additions, then you want to kind of go through that process, and it will most likely impact many users. It will impact almost all the users if it's an important module. And this is essentially that, like you want to take part in discussions, you want to talk to the maintainers, and essentially you want to make the library better. And the last step, if you are feeling really courageous, you can go ahead and develop some project of your own and put it out there, and you can try to get some traction. Uh, it so happens that like initially you may not get a lot of traction, but it's important to just go ahead and keep doing what you're doing and keep at it, because like it takes time to gain traction, even if it's a great library. So you just need to keep at it if you're actually developing something of your own. And this is a says you can't catalyst for growth of any community driven project. Like if you are making it open to the general public, you will most definitely get great results out of it. And like some of my last thoughts are essentially that open source is about giving back selflessly. Like I mean, most the kind of the mistake or like the wrong kind of line of thought that most people have is that, okay, it's Google Summer of Code. I'll just do it for the stipend, or like just getting it on my CV or something like that. While those are actually like good things, you actually get the money and you have something to brag about. But that is just one part. That's just a part of the process. And the entire uh, like the entire journey is about giving back selflessly. It's something that you want to give back because you like the project, because you actually want to see it do good. You want to make it perfect. And that's why you need to have this kind of a selfless approach, and you need to be active in the community, and you need to be empathetic towards users and maintainers. So the second point about being empathetic, it actually comes in when you are actually responding to issues on the repo. It so happens that most people don't know how to use the library, or they don't have kind of a good calibration about what how things work in the library. So what you want to do is like just be empathetic and try to guide them. If you know how to do that, how to do whatever they are stuck on, just be empathetic and guide them properly, guide them as if you are guiding yourself. And yeah, it's important to just show this level of compassion towards the users. And regarding maintainers, the thing is like these people go through like tons of issues and PRs in a very short time. So you need to be patient, you need to be like really kind towards the maintainers as well, because it's hard to just review code essentially. I don't know if any one of you has tried to review someone else's code. It's really hard because it's like reading a book, but it's not like casual reading. You need to like really go into it. You need to understand what the other person was thinking. You need to also make sure that it adheres to the actual design principles of the library, and so on. And that brings me to the next point, that always try to maintain as high of a standard as possible in your code. Make sure it's clean, make sure it's well written and well documented. Make sure that if someone else comes in your place, they can easily understand the code. These things are very important, especially as you go ahead and you write code that is going to be read by many people. And I think some really famous computer scientists said that code is meant to be read than code is meant to be read more than executed. Like it's executed once, but it's read like multiple times. So it's about writing code that can be read easily. So and also high standards also means that you think quite a bit before contributing, or like before making a PR or before contributing, because you again need to kind of adhere to that standard that the library has maintained. And lastly, the I guess the most important thing is to be respectful towards the community. Uh, know that you are part of this community, and it's something that you must maintain. Like, you must maintain this respect. You must maintain these high standards, and it's up to you to kind of just take it forward. Just make sure that you are respectful and you are in it for, yeah, you are in it just to give back, uh, because that's what open source is all about. It's about giving back. So yeah, these are some of my thoughts, and I think I'm very much near the end of my, yeah, I'm near the end of my slide deck. It's so lastly, thanks for PICT ACM for organizing the event. Thanks for having me, and thank you everyone for listening to what I had to say. And I think if anyone has any questions or queries, I am open now.
Uh, Sir, actually, we have gathered some of the questions from the students before the session. So I would like
Okay,
to ask those first. Then we can continue
sure,
with the questions from the audience.
sure.
So the first question was how to fork a project or how to start working on it. And they said, could you please explain with any simple example if it is possible?
Okay, so the question is how to fork a project and how to kind of start working on it. Is that the question?
Yes, sir, right.
Okay. So, I mean, okay, so as the person said, let me try to just explain with an example. Mm, Okay. So here I have kind of opened my GitHub repo, and let me go to the Transformers project. So if anyone already knows about this, like, this is one of the biggest machine learning libraries today, like deep learning libraries today. And it's kind of just like the de facto for any models. So I'll just give a quick overview of this repo. It's just a repo for like a lot of model architectures which you can use directly and something like that. And there are, I think there is a lot of stuff here that they have some pipelines and whatnot. Uh, but just to stick to the question, essentially what you want to do is you want to fork your own copy. It's just a button here. I think I have already forked my own thing. Yeah, I already have my own thing, so I think I'll just go back to that. Yeah, so this is kind of my own fork. And essentially, like, I have forked it quite a while back, so you can see that it's a lot of commits behind the main branch. But what you want to do is, like, let's say I'll go back to the original repo. You want to go to the issues, as I said, and you just want to start going through the issues. So, like, there are a few issues, and let me see. Mm-mm-mm. Okay, so let's see, Lava 1.5 and 1.6 not working with text only inputs. Okay, so thankfully this person has actually given us a very small code. Like, this is the small reproducibility code. Um, they have also given some other links. We'll go and look at them. So this is kind of a discussion which they have. Um, ta- ta- ta. Okay, so here it seems that this is obviously this is not something that I had looked at before. I'm just looking at it on the fly. So just to give a quick background, Lava 1.5 and 1.6 are essentially two models, like Lava 1.5 and Lava 1.6. These are two large models. Um, and what this user is saying is that so these models take in images and text and they output text. So they are supposed to look at the image, they are supposed to look at the question and then answer the question. These are the multimodal models, like a very open source and small scale version of like the GPT-4o models essentially. So what this person is saying that, hey, I cannot actually run these models when there is no image. So what we want is like if the input is just text, we still want the model to answer it, right? It shouldn't always need an image. So what they are saying is that I am not able to run the model when it's just a when it's just a text. And like I like he's saying I don't know what to do, but at the same time when they have also provided a couple links, and if we go ahead and take a look at these links, we can actually see that okay, there is some person from the uh, Hugging Face team who have responded that okay, we will be resolving this in the next release, and you can change the source code till then and install it from source uh, until like we ship this. So fortunately, like this has already kind of been resolved, or it will be resolved really soon. So that's why we actually can, yeah, here also it's like the same thing, like they have reported the same bug, but as you can see, the maintainer has kind of responded that okay, we will be actually resolving this. So I think we can look at a different thing. So, like what I did right now is essentially this is something that you want to do yourself. That okay, you go to the issues page, you see something that okay, I am looking at this, that it is kind of something that I can contribute to. You will open it up, you will start studying it, and you try to dig into it as much as possible. Now, I can go into any of these, but like the issue is that it will kind of require me to do a lot of explaining um to kind of just like give you enough context and actually make you understand it. So I think I'll not do that, but I hope you get what I'm going at, where I'm going at, that um yeah, you just go into the issues, you look at them, and if possible you create a PR from that. Yeah, so that was it.
Yes, thank you so much, sir.
Mhm.
Good evening, sir. We have some more questions. What are
Okay.
the prerequisites to get into GSoC?
Sorry, can you repeat?
What are the prerequisites to get into GSoC?
So, like the only formal prerequisite is that you actually need to just submit an application. You need to submit a proposal. Like that's the formal requirement, and of course that application needs to be accepted. But like the suggested prerequisites are, as I said, you need to be a really close, active contributor to the repo. You need to consistently kind of be looking into it and kind of be acquainted with the code, with the state of the library at the moment. Um, so I would say truly that is the prerequisite, that you already know quite a bit about the library beforehand. Yeah, I think that should answer the question.
Um, Hello, sir.
Yeah.
Another question was, what are the main skills to focus on for the GSOC?
Mm, I mean, like the really important, like two of the most important skills are like first, as I said, communication is really important. Like you need to be very open, very transparent, and like always know that mistakes are going to happen. Like mistakes are going to happen. It's important that you improve on them. So just going ahead and quickly accepting that okay, this is something that has gone wrong, and just making it work or like just quickly getting over it is important. So that's the first thing. Like you need to communicate with and you just need to be on top of everything. And the second thing is obviously like trying to maintain good standards in code, that you are actually contributing good code and it's not something that you just throw at the library, but you are actually uh, putting a lot of effort into writing that code and making sure it's up to the mark. I think these two are the most important things.
And sir, when and how should I start contributing to open source?
The earlier the better. I mean, not just about GSoC, but I think you should contribute in general whenever you get the time. So generally, I have observed that in like during generally the first 2 years of undergrad are something where you can explore things. So I would suggest that as soon as you are comfortable with some language, like at the time I was the most comfortable with the Python language. So I would recommend that as soon as you get comfort, you should start contributing to something. First, you should actually use it for some time and then start contributing. Like for example, some people, like some of my friends, they were not into much in learning, they were into web dev, into some started contributing to like GSoC is just one thing stop in the journey, so as to say, but open source is a lot more than that. So yeah.
Hello, sir.
Yeah.
Also, I had one doubt that hello, sir.
Yeah.
Also, I had one doubt that I have heard from many of the people. Also,
Mhm.
as you said while answering the previous question, that most of the selected students
Hmm.
make early contributions. So, is
Yeah.
this true?
Yes, I think it's a valid observation is that so when you say contributions, it's not just PRs. Like, I mean, many people misunderstand this and they start making random PRs and they just, like they create like a PR with like a one line change that, okay, I'll just add a space somewhere or something like that. That just adds, work for the developers and the maintainers of the library. Um, so contributions can come of the library. Um, so contributions can come in any way. Your slides were shown. Um, contributions can be in form of obviously solving issues or making PRs, but they can also be in the form of like blogs or like some content or just something that the community needs. So, for example, when I was working on Keras, I realized that I realized that it's difficult to kind of build Keras from source. So just in case someone is wondering what's building from source, it's like you download the source code and then you compile it like by yourself. Instead of, as I said, downloading the exe file, you download the source code and then you compile it yourself. Roughly, it's that. So it was difficult and it was error prone to do that on the Google Cloud VMs, especially with TPUs. So I wrote a small blog which just outlined this clear cut kind of procedure. And in my opinion, that's a decent contribution. Like that is not something that the library will do directly, that the library will include in its, repository directly, but it's something that you can always have, because it's something that you can always show because it solves a legitimate problem. And actually at the time I had even asked like the repository members that should can we merge this, like they said no, it's good and we are open to giving feedback for the blog, but we won't maintain it in the repo because it we will always need to update it with the new version numbers for all the involved packages. So that's the reason they said like we wouldn't want to maintain it. But yeah, so that's a good contribution, so as to say. So yeah, I think that should answer the question.
Also, sir, I was in the situation that suppose I have started making early. Most of the medium level or good for beginner level issues have already
Mhm.
been assigned. So, what approach should I take in that case?
Yeah, I mean the good first issue tag is something that the that it's something that everyone is going to look at. Like most likely, if let's say today I see right now there are like 27 people in the meet. Okay, so if all of us just go to some library and start looking through the issues, everyone is going to look at the good first issue tag first, right? So of course that is going to be solved very quickly, and many people will be there trying to take it. What you want to do is leave that. You just go to the issues page like I went right now, and you just start seeing whatever you can understand. Okay, this I have not exactly been involved in like I have not exactly been involved in like the open source machine learning side. I have more interested in something else. So yeah, I don't think that's something that I can answer really well. But what I would recommend is that the best thing to contribute to is what you work on. So if I'm not sure who asked this, but like whoever asked this, like if they are working on, let's say, web dev or crypto or whatever, essentially, it doesn't matter. Whatever you are working on, if you are using open source software, just start with that. Contribute to something that you are familiar with, and if you are just starting out and you don't know what you want to do, I think that in that case you should kind of hold back. You should not start contributing right away. You should just first try to learn whatever you want to learn and then contribute, because as I said, if you want to contribute, you need to know what you're doing. It's not like you can just go and do something. So yeah, like in that case, first try to learn about something and then try to contribute. But yeah, I don't think I can point to some trending tech stacks or something.
Sir,
I
we have
think that,
one more question from our audience.
okay.
When did you start
Yeah.
learning ML? Did you explore the depth of it by yourself? For example, the mathematical details. I want to get into ML as a career option. Should I learn ML from somewhere before exploring open source?
Yeah. So okay, so like I can actually talk about this for quite a bit, but I think I'll try to keep it short. Uh, so the answer here is okay. So I think I'll just go question by question. So when did you start learning ML? At the beginning of my second year. So it was what, mid of 2020, or like June, July of 2020. That's when I started. Did you explore the depths? Yes, I kind of. So I was doing this deep learning specialization on Coursera. At the time, it was free during COVID. So I was doing that, and I was actually just rushing through it very quickly. Like I was trying to rush through the courses, but I was in the middle of it and I realized that I haven't learned anything, that I just rushed through it and I didn't understand anything. So that's when I kind of stopped and I went back and I took like 1 or 2 more weeks and I tried to understand everything. And I think that one small step actually improved my understanding by quite a lot, because, and yes, did you explore the depths of it? Like, I don't know what this person means by depths, but yes, I did go into the mathematical details because, uh, so if anyone knows about deep learning, it's essentially like given a model, for training, you do a forward pass and a backward pass. And if you are just starting out, the backward pass is something that generally is confusing. So I did spend a lot of time actually computing the backward pass by myself, like by hand, because you have to calculate partial derivatives and things like that. And it can get tricky. It can get really tricky really quickly. And uh, so you need to kind of give it a lot of time. And I think anyone who wants to look at this seriously, they should give this time, because if you don't understand backprop, you can't just visualize anything. You will be really limited by like whatever. Yeah, you can't do anything essentially. So yes, I think it's recommended to just uh, go into the details. And the last question is, I want to get into ML as a career option. So should I learn ML from somewhere? So before exploring open source. Um, so here's where I would like just give a broader view about machine learning. So as a like just a disclaimer, I am still a student. I haven't got into the job market. I don't know anything about like the as a career option part. But uh, the thing is like, oh, for me, open source helped because like even though I am doing research right now, I am more of an engineer than a researcher. So uh, that for that open source was a big factor for me, that I actually kind of got to interact with the code, and I really like the development aspect of it, the engineering side of it, rather than like uh, just going ahead and trying out new models. Like I wasn't just concerned about the theory or like the um you know just the overarching concepts, but I was very interested about the code and the like the lower level, like hardware level and that kind of stuff. So that's where I really liked going into, you know, sorry. That's why I really liked kind of looking into open source, because that is a very detail oriented field. So like, should I learn ML from somewhere? So yes, if you are looking at ML, definitely you need to learn it from somewhere. As I said, I looked at the deep learning specialization. It's not necessary that you need to look at exactly that. You can just go ahead and look at anything. As long as you are doing it diligently, as long as you are actually putting in the time and you are understanding everything correctly, that should be enough. Um, I would recommend the deep learning specialization to start with, but you can start with whatever you want. It's no big deal. Like you can start with anything that suits you. Yeah, I think that should answer it.
So, sir, can we start with the questions from the audience, from the attendees?
Sure.
So, anyone who have doubts, just raise your hand. We will turn on your mic so you can ask the questions.
Thank you.
Yes, Daksh.
So, sir, my question was, if you are just starting to contribute to open source, how do we find good and impactful projects on GitHub? As there are like number of projects available, but many times the community is not active, or it's not really making an impact on the current scenarios.
Yeah, I think as I said earlier, like it's something that you choose by yourself. That I mean, if you are, as I said, like if you want to work on something like a web development or something, go into some projects about that. Like I'm, so I know that like something like React or like Django is an open source project. So you can just first learn about those things by yourself, like try to get acquainted with it and then go into that. So like to answer your question, like which projects to choose, I think like as you kind of go more into your topic of interest, you will like automatically find the right things that you need. You won't need to go ahead and search for them. So I would suggest that on what you want to actually learn. Like let's say here in my example, it's web dev. So you kind of first focus on learning that. And after some time, you will naturally understand, okay, I can start contributing to this project or something. So yeah, I think it's, let's say I want to contribute to React or something. So yeah, it's like that.
Also, sir, I had one more question. How do we familiarize ourselves with the paradigms to be followed while writing an open source or contributing to it, to be specific?
I think like so if you kind of have, I mean, as I did right now, I went to the Hugging Face repo and I just opened the issues and I started looking at it. So like let's say this happens, that you go to the issues tab, you start interacting with the maintainers or something, and you start kind of making PRs. So um, first, like as you are using the library, you will already start understanding how the use from the user perspective. But as you start or bug fixes, you will start going through the code, and like if you look at it for a long enough time, you will start looking at some patterns and concepts, like you understanding how the library works in itself. So that's when you will actually get acquainted with the paradigm by yourself. So it's not something like, okay, there is a document or something. Generally one or two paragraphs, but it's not something that you can just imagine after looking at the document. You actually need to work with the code to understand what they mean, because generally that document is like really abstract. You can't understand. Like, you will read it and be like, okay, what does it mean? So you'll need to look at a lot of code before you can, before you can actually understand what's the paradigm.
Okay, sir. Thank you.
Yeah. Yep.
Any other questions?
Do anyone have more questions? Okay, so thank you, sir. On behalf of the PICT ACM Student Chapter, I would like to extend my heartfelt gratitude to Mr. Aditya Kane for taking the time to guide us through this insightful session on mastering GSoC. Your knowledge, experience, and practical advice have truly inspired us to explore open source and aim higher in our journeys. I would also like to thank our audience for their enthusiastic participation, for making this session engaging and interactive. Once again, thank you, Mr. Kane, for sharing your expertise with us, and we hope to have you with us again in the future. Have a great evening, everyone. Thank you.
Thank you for having me. Bye bye.
Thank you, sir. Once again, thank you, Mr. Kane, for sharing your expertise with us, and we hope to have you with us again in the future. Have a great evening, everyone. Thank you for having me. Thank you, sir. Thank you, Mr. Kane, for sharing your expertise with us. Have you with us again.
you.